Hello and welcome to Geology 12. I'm going to work on exercise 20 and a little bit of exercise 19 for this class. And we did most of exercise 19 in class, although we didn't get to this activity on Kepler's third law, and also we didn't do the experiment with the heating. Maybe we'll do this in class next week if there's time, but certainly we can do this activity with Kepler's third law. And what I'd like to do is go over here to the document camera and maybe do some of these exercises or activities just to show you, how to work this. So remember, when we're doing Kepler's laws, the third law is basically the period of rotation. In other words, the number of years it takes, or days it takes, for the planet to go around the sun is proportional to the cube cube of the distance, in this case in astronomical units. And so here they're saying, well, if a hypothetical planet is 4 astronomical units away, then how would you calculate its period, right? So let's look over here. Basically, it's P2, the period of rotation squared, equals the distance cubed, right? And so we'll do an experiment, right? So if we go back to our graph here, we'll pick a planet that we already know, right? In fact, I know that Jupiter, we go over here, I know that Jupiter, astronomical unit distance of 5.2 astronomical units, right? So basically, P squared equals that distance, 5.2 cubed, right? And then let's do the calculator here. We'll solve for that there. So if we bring our calculator up here, we'll say we have 5.2 astronomical units. And I'm going to click this symbol here to make x 5.2, and I'm going to make it to the third power, which is basically 5.2 times 5.2 times 5.2, which is basically 141, right? So P squared equals 141, right? So now if I take the square root of both sides, then I get P just drops out of here, right? Because I take the square root there. So the square root of 141, if I come back here, I just take the square root of this here, I get 11.886. 11.86. So that would be in years, right? For the period for Jupiter, right? So let's go see what the actual number is. Jupiter is something that's known. Well, here are the planets right here. So Jupiter, it's 12 years. So we got what, 11 points. So we got pretty close, right? Now, what I want you to do for this experiment is you're taking this hypothetical planet that's 4 astronomical units away. So just plug in the same thing. Plug in the units there, just like I did on this experiment, and see what you get, right? Now I want to get back and start on exercise 20, locating the planets. And it's pretty straightforward. I want you to read through this and work on it, and I'll show you two, not really complicated, but it's lab that require a little bit of effort here. And the first one is this plotting data on this figure 20.1 using the reference circle here. And they use this, they call it planetary heliocentric longitudes, which are basically these degrees that are going to be plotted on this outside circle. And the way you want to do it is you want to follow these steps, right? So we're going to determine the location of the planet on whatever date. So here we're going to look at basically March 22nd, April 22nd, May 22nd, right? And we're going to be looking at Mercury, Venus, Mars, and Jupiter. Even though Jupiter doesn't lie within the inner solar system, we can actually plot Jupiter kind of outside over here, right? But we still can figure out where Jupiter is and basically what constellation it's going to be. Because here you see there's an orbit of Mercury, the orbit of Venus, the orbit of Earth, and then the orbit of Mars out here. And then the other thing to pay attention to are the months. And note that the months go June, July, August, September. So they're getting larger, or going counterclockwise, because remember, if you're looking from the North Star down onto our solar system, all the planets are orbiting the sun counterclockwise, right? And also the planets are spinning eastward, or in that counterclockwise direction. And we'll need to know that for a part of this lab as well. The way we're going to do this, in fact, they want you to, and I put this in there, which basically you already have the data up here. So we're really going to plot this data, because in the original lab they had a bunch of other dates. So we're just going to plot these dates. And note that we're going to do it for really all 3 of these, but I think they want to start off March 22nd. So using the So basically this number, table 1 is going to ask you to place, like, where is Mercury on March 22nd of 2023? Well, it's at 23.6 degrees. So you probably don't even need to fill this table out because you already have it up here, is what I'm saying. So I probably should just eliminate this table because I've already given you the data up here. So, and then for number 2, you want to use that data up here to plot on that figure 20.1. And the way you want to do it, and I recommend using colored pencils. And what I was using a pink for Mercury, an orange for Venus, blue for Earth, and red for Mars, right? So let's plot the Mercury data. So again, you're going to need some colored pencils and a ruler as well, right? Let's go over to the document camera. And what you'll see is, you'll see that for Mercury on March 22nd, the angle is 23.6 degrees. So you would go on the document camera on the outer circular to 10, 20, 21, 2, 3, and put a little dot there, right? Then you want to draw a straight line from that dot to where the sun is, right? And you can draw a really faint line because you don't really need that. That's only for your guidance to where you're going to plot. And where that line crosses the orbit of Mercury, that's where Mercury is, or Mercury will be on March 23 or 22, March 22. So then, remember I'm using pink for Mercury, then you put a little circle there for Mercury, right? And then if we go back to the data table there, on April 22nd, Mercury will be at 190 degrees, right? So for 190, we see it's way out over here. You put a little tick mark there. And now, since I already know it's going to be a straight line there, I'm just going to see where that line crosses the orbit of Mercury, and I'm going to say Mercury is going to be there, right? And so, remember, this one here was for March 22nd. This is for April. I'll put 4/22 here, for April 22 of 2023. And then if we go back to the table 20.1, in May, it's at 280. So at 280, which is going to be down over here, 280, and we draw a straight line to the sun, and we see that we put a little tick mark there, and we're going to draw Mercury there for May, which is 5/22. So, and then remember, also the lab's going to ask you to draw the directions that Mercury is moving, right? So remember, it's orbiting counterclockwise as viewed from the northern hemisphere. I've done Mercury. Obviously, for Earth is going to be pretty easy because we have dates already for Earth here, right? And so we know, for example, on March 22nd, we're just going to put a circle there. In fact, I think they want us to make kind of a larger circle because later on we're going to do something with this circle. And then for April 22nd, put another circle there. And this one I don't even have to label the date because it's already on the circle here, on this outer circle. And then for May 22nd, which is going to be right over here. All right, so with your job, if we go back to the data table, I want you to plot the dates for Venus, right? Both March 22nd, April 22nd, and May 22nd, and make sure you label those dates on that figure 20.1. Do Mars as well, and then, in fact, I'll do a couple for. In fact, we can do Jupiter together because you can see they're all really closely spaced because Jupiter, remember, it's farther out. It takes 12 years for one orbital period, right? So it's much slower than the inner planets. So it's not moving very much compared to, for example, Mercury is moving very fast. You can see it's swung about 175 degrees in 1 month, right? So it's swinging pretty fast there. All right, so let's go back to the document. We'll do Jupiter, and I was using this purple color for Jupiter. So the first thing I see is that Jupiter in March is at 20 degrees. So I go to 20 degrees, and now what I'll do, if I draw a straight line going through 20 degrees, I'm going to show that Jupiter is going to be out over here somewhere, right? So I'm going to kind of draw a larger planet out over here and circle that in. And then on April 22nd, it's at 23 degrees, right? So really didn't go very much. So 1, 2, yeah, right there. It's going to just move a little farther away. So I'll draw a circle in there for Jupiter on the 23rd, for April. And then for May, it's at 25.5 degrees. So 25.5. So it's kind of big. So basically you can see it's not really traveling very much. So there's a circle for May. Here's a circle for April, and here's a circle for March, right? So if we can put those dates, this would be 3/22, 4/22, and then 5/22. So that's what I want you to do for Jupiter when you're plotting Jupiter. So also what they're going to want you to do here for question 3, once after you've plotted all these planets, is you want to see how much Mercury moved in 1 month. And really what you want to do here, the easiest way to do it is just go to the data table. So Mercury moved, basically you take 191 minus 24, right? Which is basically 176 degrees, right? So it moved considerably, right? About 176 degrees. That's how much moved. And then for Venus, basically you would take the 140 minus 90, which is what? 50 degrees. It moved 50 degrees, right? So again, I'm just doing the math here. I'm subtracting the larger number from the smaller number. So do that for these planets. And then for Earth, we don't have the Earth data, but for Earth, just go to the diagram, figure 20.1, right? And then figure out how much Earth moves in 1 month, right? So you can see Earth here in March is about 180 degrees, but in April it's at about 210, so it's moved about 30 degrees, right? So you can just kind of calculate it from the diagram itself, right? In fact, it says from the Earth's orbit, figure this out. And then you do Mars as well. And then for activity 20.1, here we're going to be looking at what constellation the planet could be in. For example, Mercury. So in this case, now you want to go, for example, in here wants March 22nd, right? You go to this, to March here, and you want to draw, in fact, we'll do the purple line since we're using purple for Mercury. You want to draw a line from Earth through Mercury, kind of a very faint line, and see what constellation it ends. So it ends up in Pisces. Mercury will be in Pisces in March, right? And if we went to, let's go all the way to May. If we drew, so now we have to go through this May here and Earth's May here. So if we drew a line here, we see that in May, Mercury would be in Aries, right? So it would have changed, right? So anyways, so once you plot the other planets, Venus and Mars, you want to basically figure out what constellation those planets are going to be on by looking at the outer circle here in the constellations. So that's a pretty straightforward, pretty easy. And then you can answer this question. For example, well, they don't have Mercury, but Mercury was, according to our diagram here, in 2 months, right? So they do want you to go out 2 months. So for Mercury, we found that Mercury in March was in Pisces, but in May it was in Aries, right? So it changed. So you do the same thing for Venus and Mars, right? Now we're going to compare the orbital periods of planets, right? For this, just get the data off of exercise 19. In fact, I got rid of it here. Let's bring it back up here. And that's go into this table here, right? So for example, they want to know the astronomical distance of Mercury and its orbital period. So I think Mercury is 0.39 astronomical units, and the orbital period is so 0.39 and then 88 days. And make sure you put days, and you can see once you get to Jupiter, it's years, right? And Saturn, and in fact, they don't even ask for Saturn. They want Neptune, 165 years. So you would put, so Neptune's at around 30 astronomical units. Yeah, 30.06, and it's 165 years. So make sure you put years or days, depending on what they give you there. So just get that data off of this table 19.1. You'll fill that out, and then using the information you compiled from question 2, write a brief statement about comparing the orbital period of the planet and its distance. So basically, the farther you go out, the larger the astronomical unit, the longer the orbital period, right? How many orbital orbits will Mercury complete in 1 year? So it takes 88 days for one orbital period for Mercury. So basically 365 divided by 88. You get 4, so a little over 4. So it goes around 4 times, because remember it's 88 days. And what fraction of orbit will Mars complete in 1 year? So here we know that Mars has a orbital period of 687 days. So that's about twice, almost twice. So basically, it would have gone maybe a half of rotation, right, around the planet, 50% of its orbital period. So anyway, just do the calculations on that. It's pretty straightforward. That's for Mars, and Mercury did that. Now this next part here deals with this retrograde motion, and I talked about it in my other video. And so for this, what I'd like you to do is when you're plotting it, and I actually did it already on another sheet over here. So again, this one's pretty straightforward. If we look at what I've done here, I've basically taken their instruction, and they've already done line 1 for us, right? But then you do line 2, you draw point number 2 up here, line 3, line 4, line 5, and then line 6, and then you connect these dots, right? And it shows that retrograde motion, because really your Earth is passing Mars as we're both orbiting counterclockwise around the sun. So you want to show something like that on your figure there. All right, so that's activity 20.3, and then you can answer these questions in more detail. This next question, 5, 6, and 7, and 8 deal with this picture, and you can see that you're going from January to February to March, April, May. So basically from April through really July 1st, we're in retrograde motion, and then we're beginning in July, we get back to normal motion here, right? So you can answer the questions there. They're pretty straightforward. And then, okay, here's the other one that was a little tricky. So for this activity 20.4, we want to do some editing on our figure 20.1, right? So they want you to edit or do some work on this 20.1. And so let's see. So step 1 on figure 20, indicate the position of a planet to be observed and Earth's position of the desired date. So we'll see what they want us there. And then here's where they want us to make Earth kind of dime size and mark the locations of noon, sunset, and midnight. So I'll show you how to do that in a moment. And here in fact, I think this is incorrect, because remember the planet is going counterclockwise around the sun. Both Mars and Earth are going counterclockwise, and they're also rotating counterclockwise. So really this should be 6 a.m. and this should be 6 p.m. So they have it kind of backwards here, and I'll fix it on our diagram here. And then step 3, you want to draw a line through the circle so that it separates the half of Earth facing the planet to be observed. So that's what they're kind of doing here. So basically this half of the planet is observing Mars, right? This half cannot see Mars, right? Keeping in mind that Earthbound observers must be on the half of Earth facing the planet to see it. Note the 2 places where the line from step 3 intersects Earth's surface. This will be the times the planet will be first visible when it rises, and then when it's no longer visible is when it's set, right? So we want to use actually I should have fixed it. I want to use the March 22nd date of 2023. So let's do the March 22nd, and we'll see let's do Mars, because Mars should be visible to us if we do our star party next week. So again, March 22nd. So I did have March 22nd here, but since I didn't plot Mars, I'm gonna have to plot Mars on our diagram here. So let's go to Mars on March 22nd is at 1:26. So I'm using red for Mars. So we'll come back to the document camera, and we'll go to 1:26, which is right here, and then we'll draw a straight line from the sun out to 1:26, and where it crosses Mars' orbit is right here. So Mars will be here on March 23rd or 22nd, the day we plan to do if there's no rain, right? So we'll put Mars there. So then from Earth, right, we're here. So what they want us to do is since we're doing Mars, I'll do the red line here. We want to draw a line across Earth here. So only this side of Earth will be able to see Mars, right? This side over here. And then also what they wanted to do is to put where noon is, right? So obviously if you're facing the sun, it's noon here, it'd be midnight on this side. And then remember, Earth is rotating eastward. It's spinning eastward. If I can draw the arrow there, right? So that eastward rotation, spinning this way, which means that this must be so as you come around here, you're at midnight, you're early morning, so it's 6 a.m. right here. So this is going to be 6 a.m. right here. Then as you spin around, it's high noon. This must be 6 p.m. over here. So that's what we want you to do. And then if we go back to the questions, when will Mars rise, right? So Mars will rise. If we go back to our diagram, you'll see that it becomes first visible. If you're on Earth, it'll be at noon. It'll be first visible at noon, and then it'll set at midnight, right? So going back here, Mars will rise at 12 noon. We can't see it because the sun is blocking us, but once the sun sets, and it's going to set around 7:20, 7:25 this week coming up, then we'll be able to see it, and we'll see it basically up until it's going to set around midnight. So we should be able to see Mars pretty well. So on March 22nd, what are the best times to observe the following planets, right? So Mars, we should see it from like maybe 8 to 10 p.m. would be a good time to see it, right? And so now, based on how I just showed you, you want to do the same idea for Mercury. In fact, let's look at number 3 here. So if we're here on Earth and we want to go to Mercury, so again, noon is here. So remember, Mercury, I'm using pink, so I'm going to draw a pink line going. So Mercury is right there. So I'm going to draw a line like this. So basically, for Mercury, we won't be able to see it because Mercury is basically going to rise at 6 a.m. and set at 6 p.m. It's behind the sun. It's in Pisces. We won't be able to see it, right? So Mercury is not going to be really observable to us because it's behind the sun right now. Based on your model, well, tonight, and so really what I'm thinking about is either Monday or Wednesday when we do the star party, between 6 p.m. and midnight would be a good time or poor time to view Mars. So yes, we'll see Mars. I'll let you figure out Venus. And Jupiter, you could, do Jupiter. So again, for Jupiter, you kind of do the same thing that I did for Mercury there and Mars. There is one more planet we should be able to see, and I think it's Uranus, and I'll explain that on the night we do the observation. So Uranus should be available, but Uranus is so far away we may not be able to see it. It's going to be probably too faint for us to see. So anyways, that's it for this activity. Again, most of it's just reading and going through the details here, but I showed you the complicated parts. I'll see you guys in class next week.